Welcome back to Grade 9 Applied Mathematics. Continuing our work in Unit 9 Geometry. We're down to 2 lessons to go on the entire course. This one is Lesson 3, and we're going to be looking at the sum of exterior angles in a polygon. Yesterday we looked at the sum of the interior angles. So let's try a bit of a review, see what you remember about yesterday. Can you figure out what the measure of angle A is? Our first time to ponder pause. Okay, resuming to take this up. This is a quadrilateral. It can be split into 2 triangles, so the sum of the interior angles should be 360. So I know that A plus 105 plus 93 plus 47, all of that should be equal to 360. And when you add these up and you subtract from 360, you get that A is 115. So that was our new learning yesterday. The sum of the interior angles in a quadrilateral, 360. I mentioned today we're going to be looking at exterior angles. So the first thing I have to start with is making sure you understand the difference between an interior angle and an exterior angle. So an interior angle is formed by 2 adjacent sides in a polygon. So there's this side and there's that side. They make this angle here. Those are 2 of the sides in the polygon. Change the pen color. What is an exterior angle? It is an angle contained between one side of the polygon and an extension of an adjacent side. So notice this angle right here, it's comprised of this piece, which is a side in the polygon, and this piece right here, which is an extension of this side. So to create an exterior angle, you extend one side, and then you draw the angle between that extended side and the side in the polygon, as I've done here. So if we were meeting in class, this is where we go to next. We'll see what we can do with this. I'm going to put the pen down. I need to make sure before we start that you understand the difference between an interior and an exterior angle. So I'd have this sketch up there, and I will try to see if I can upload this sketch to the LMS so that you can do further practice, because every time you click on it you get a new one. So this angle has popped up here, and the question is for you to decide, is that exterior, interior, or neither? And if you would like to pause as we're going through these at any point in time, please feel free to pause. There's 10 examples to go through, so I'm not going to hit pause each time. I'm just going to take a look at what I have here. That angle is created by extending this side. I see how that side there has been extended, and this is a side in the triangle. So this is definitely an exterior angle. So that one was an exterior angle. Let's move to number 2. And let's take a look at what's happening. Is this an exterior angle? And most students will tell me, yes, it is an exterior angle because it's on the outside, but it turns out it's not following the definition of an exterior angle. That's an extended side. This is an extended side. In fact, this angle is equal to this angle here. So I call it equal to an interior angle. It has the same measure as an interior angle. It's not an exterior angle. Remember, an exterior angle would be this one here, created by an extended side and a side, or this one here, created by extending this side and this side. This angle is between 2 extended sides, so it's not exterior, it's not interior, but we could call it equal to interior, or maybe you want to call it neither. All right, on to 3. What is number 3? So taking a look at how this was created, we have an extension of a side here, and we have a side right there. So this meets the definition of an exterior angle. So number 3 is an exterior angle. We've extended that side, and that's a side in a polygon. Let's look at number 4. What is number 4? And if we take a look at 4, it's created by this side in the polygon and this, which is a second side in the polygon. So this is the definition of an interior angle because it was created by 2 sides of the polygon. On to number 5. Is that interior, exterior, or neither? A lot of students think this is an interior angle because it is inside the polygon, but that's not the definition of an interior angle. Let's take a look at how it was created. It was created by this, which is not a side in the polygon, nor is it an extended side. This is not a side in the polygon, nor is it an extended side. So this one's definitely a neither. It's not exterior, it's not interior, it's not equal to the interior, it's a neither. On to number 6. So what kind of angle is number 6? So it looks like it's on the outside. Is it an exterior angle? So let's take a look at how it's created. This is definitely, so one arm of that angle is definitely a side in the polygon right here. But this other arm over here is not an extended side. We didn't create this line segment by extending this side. So this one is definitely a neither. It's not going to be equal to an exterior measure, won't be equal to an interior. This is a neither. Again, why? Created by a side in the polygon, but this side here is not an extended side, nor is it a side in the polygon. That's why this one's a neither. All right, on to 7. What is 7? Let's take a look at how that angle was created. So arm 1 of that angle is a side in the polygon, and arm 2 is also a side in the polygon. That's the definition of an interior angle formed by 2 sides of the polygon. On to number 8. What is number 8? So taking a look at how this angle was created, we have a side in the polygon, and this piece here is an extension of this side. So that is the definition of an exterior angle, formed by one side of the polygon and an extension of an adjacent side. So this side has been extended, creating that exterior angle. All right, moving on to number 9. What is number 9? Is that exterior, interior, or neither? So taking a look at how this was created, we do have a side in the polygon right here, but the other arm here is not a side in the polygon, nor is it an extended side. So this is not an exterior angle, it's not interior, it's neither. I suppose we could say it's part of. The angle that goes from here to here is interior. It's part of an interior angle, but it is not the whole interior angle. All right, one last one to look at. What is number 10? Exterior, interior, or neither? And if we take a look at this, we can see how was it created. Well, it's part of a side, right? So I suppose we can argue that arm is a side in the polygon. But this arm here is not an extension of an adjacent side, nor is it another side in the polygon. So this one is going to be a neither. And again, I'm going to try and post this in the LMS so that if you're still struggling, I don't see the difference between an interior and an interior, you can go through this again. It'll randomize and give you a different example. Because I won't be explaining it to you, you can always click on this. And then you will be given some hints over here telling you why. All right, moving forward now. What I would like you to do is, I've got a polygon here. I bolded it, but maybe I'm going to go over that with a highlighter just so that you can see the sides I'm talking about. So we've got a side there for our polygon. There's a side there, and a side there. So what you're going to do is we have 16 angles marked here, all around each vertex, a circle around each vertex. Label each of those angles as interior, or you could also label it as equal to the interior, and exterior. So again, a time to ponder pause. Just put out the letters of the angles that are interior, the letters of the angles that are exterior, and we should add the angles or the letters that are equal to the interior angle. And again, a time to ponder pause. All right, resuming. The interior angles are here because that is formed by, so I better go back to the pen. The highlighter straightens your marks out. So that is formed by 2 sides in our polygon, this side and this side. This is formed by this side and this side. Those are sides in the polygon. That's formed by this and this. Both are sides in the polygon. And this, they're both sides in the polygon. So A, B, C, and D are our interior angles. Now let's take a look at H. So H, let me change the color to blue just so that we can see how H is formed. Those are 2 extensions. We extended this side and we extended that side. Same for E. E is created by extending this side and extending this side. F is created by extending both sides, as is G. So by the opposite angle theorem, H will be equal to an interior, so will E, so will F, and so will G. Now they technically don't meet the definition of an interior angle, so I've written equal to the interior angles are E, F, G, and H. Changing my pen color one last time just to walk you through a few of these. Why is I an exterior angle? So it's created by this side, which is an extension, and this one, which is a side in the polygon. J is created by a side in the polygon and an extension. K, side in the polygon and extension. F, side in the polygon and an extension. M, side in the polygon and then the extension. N, side in the polygon and then that extension. O is created by this side in the polygon and that extension. And then finally we have P, which is created by this side in the polygon and that extension. So that gives us I, J, K, L, M, N, O, and P are all exterior angles. And then before we move forward to do any math, just to make sure that you had totally grasped this concept, I would have you draw an exterior angle off each vertex. Now, if we were meeting face to face, I'd be looking at your whiteboards, and I'd be checking to make sure you mastered the concept of exterior angle. So if you have a piece of paper in front of you now, draw a triangle that looks like this one and see if you can draw an exterior angle off each side, and then I'll show you possible answers, and then you can check yourself to see if you are correct. Again, a time to ponder pause. All right, resuming. I'm going to show you one way we could do it is I extended this side, and then we've got this side here. So there's the exterior angle created by this side and the extension of this side. Extending this side and the angle between that side and this extension, that's exterior. Extending this side now between that side and this one. It is also possible that I could have done it differently. I could have extended this side like that. Let me just try to do that with a straight edge. Change the color to show you a different option. So we could have extended that one. And over here we could be extending this one. And then over here we could be extending this one. So it's possible you extended the other side rather than the one I did. And so now changing the pen color, it's now green. There is an exterior angle between this extension and that side. There's an exterior angle between this extension and this side. And then there's another exterior angle between this extension and this side. So those are the 6 exterior angles that we could draw off that triangle. All right, so hopefully we've mastered that. All right, so what we're going to take a look at first is exterior angles of a triangle. Just going to wait for this to load up. And we're going to try and figure out what is the sum of these 3 exterior angles. Now, hopefully I don't have to review this anymore, but we can tell that they are exterior. There's a side and an extended side. This is a side right here. This is the extended side. That's a side, that's the extended side. So those 3 are exterior angles, and I'm wondering what their sum is. So I'm going to drag this like this. And what has it created? Let's look at a different visual for this one. This visual looks like this. Whoops. You have to wait for that to load up again. All right, so there's the triangle. You can confirm before I begin that each of these are exterior angles. Convince yourself why that's the case. And now I'm going to slide that. And now the whole thing is collapsing to that point. What's true about this? And one more visual that we're going to look at. So again, here's a triangle. We've got those 3 exterior angles. And again, we'll wait for it to reload. We've got those 3 exterior angles there. And what happens when I move this? 2 of those angles are going to slide up to meet at a vertex. And then what's happened? So we can still see them over here. What's happened in each case is they've made a complete revolution of a circle. How many degrees are in a circle? And then what's your hypothesis for the sum of the exterior angles in a triangle, given that in each of these 3 cases they've made a circle? I'm not sure if I go back to this one, if it's going to reset. And it looks like it is going to reset. Oh, there it is there. So it did make a circle. So it looks like the sum of the exterior angles in a triangle, 360. All right, so what we've got coming up next is a quadrilateral. And so convince yourself that each of these are exterior angles, that and that, that with that, this angle with this piece and that piece, and this angle with this piece and this piece. So convince yourself why those are exterior angles. And what do you think will happen if we try and find the sum of these? So I'm going to show you what happens. So as we slide around, we pick up each angle, we come over to the corner. They're all on one vertex, and it looks like they've made a complete revolution of a circle again. All right, let's move on to the next slide. So we've looked at a triangle, 360 degrees, sum of the exterior. We've seen in the quadrilateral, the sum of the exteriors was 360. Now this is the pentagon again. You should look at this picture, convince yourself why each one of those 5 angles is the exterior angle. What do you think is going to happen when we pull all of these together? What do you think the sum will be? Now I'm going to show you what will happen. Each of those move around, we pick up the other one, we come over to there, and now we can see that we've made a complete revolution of a circle. So coming over here, what did you notice about how they're lining up? What can you conclude about the sum of the exterior angles of really any polygon? And again, we'll take a time to ponder pause. All right, so just resuming. Hopefully we're noting that it looks like they were making a complete revolution of a circle. We're getting 360 degrees. And just for further convincing, I'm going to show you this particular sketch. So this is coming from Geometry Sketchpad. We'll start this up and notice how the polygon collapses and then it expands back out. It's going to collapse and expand back out. So what I'm going to do is start adding sides to it. These are regular polygons in this particular case. So we started with an equilateral triangle, we're going to a square, the next one is going to be a regular pentagon, and so on. So notice when it collapses, full revolution. We'll go to the hexagon. Note when it collapses, it's made a complete revolution of a circle. And notice how as I add more sides, the exterior angles have to get smaller. And every time it collapses, we're at a 10-sided figure right now, it collapses into a circle, a complete revolution of a circle. I'm going to add more sides. Notice how the exterior angles decrease in size. And I'm going to see how close we can get there. I'm going to pause. So notice when it completely collapses, we've gone a complete revolution of a circle. So it doesn't seem to matter how many sides you have in your figure. Just as you keep adding more sides, notice how those exterior angles are getting smaller, and we're making a complete revolution of a circle. So coming back to our note then, the sum of the exterior angles in any polygon is 360. That's different from the sum of the interior. So maybe I'm just going to type that, sum of the interior. So yesterday we learned to find the sum of the interior angles, we have to use this formula, 180 times n minus 2. But it doesn't matter how many sides your polygon is, the sum of the exterior angles is always 360, so that one should be easier to remember. All right, now that we've derived that, and hopefully we have a good understanding of it, we are now ready to do some practice problems. So starting with this quadrilateral, well, what did you learn about the sum of the exterior angles? What should those 4 angles add up to? And then find the missing measure. Again, a time to ponder pause. All right, resuming to take this up, what we should have determined is that it really doesn't matter what polygon you are, the sum of these exterior angles, and convince yourself again that they are exterior. Extended side, side. Extended side, side. Extended side, side. Extended side, side. They definitely are the exterior angles. So the sum of all 4 of those should be 360. X plus 130 plus 110 plus 85. If you add those 3 numbers together, you will get 325. So to find x, it should be 360 minus 325. So x is 35 degrees. All right, see if you can find the missing measure over here. Now, there's a bit of an added challenge here because there are 1, 2, 3, 4, 5 exterior angles, but I haven't, this is the unknown, but I didn't give you the measure of that one, but you should be able to figure that out. So figure that out first, and then remember what's the sum of the exterior angles in any polygon. Again, a time to ponder pause. All right, resuming to take this up. So I'm going to start, I need this exterior angle, the measure of this exterior angle. That's a straight angle right there. So I do know that this angle plus 150 needs to be 180. And 30 plus 150 is 180, or alternately 180 minus 150 is 30. So that's 30. Again, you should convince yourself that each of these is an exterior angle because they were all created, or each one was created by a side in the polygon and an extension of a side of a polygon. So I now know that x plus 30, plus 70, plus 95, plus 45 needs to be 360, because it doesn't matter how many sides your polygon is, the sum of the exterior angles is always 30. If you add those four numbers together, you'll get 240. So I now know that x is 360 minus 240, which is 120. All right, another example to look at. A regular polygon has an exterior angle measure of 72 degrees. Now remember, regular means that all of the exterior angles will be equal in measure. So which of the polygons below is the correct polygon? Again, count the number of sides. That'll be the number of exterior angles. They've told you what the exterior angle measure is, and you should remember that the sum of the exterior angles in every regular polygon is supposed to be 360 degrees. All right, a time to ponder pause for you to figure that one out. All right, resuming and taking this up. This one has 8 exterior angles. There's one there. There's one there. One there. One there. One there. Continuing all the way around. One there. And then one there. So we have 1, 2, 3, 4, 5, 6, 7, 8. 8 exterior angles. If they each have a measure of 72, then 8 times 72, if this were correct, would be 360 degrees. But 8 times 72 is much greater than 360 degrees. So this one can't be right. Off of here, we have 6 exterior angles. Drawing them all. So 1, 2, 3, 4, 5, 6 exterior angles. They told us the measure of an exterior angle is 72, so I'm going to check this. 6 exterior angles times 72 degrees, that is not equal to 360. In fact, that is greater than 360 as well. And on this last shape here, we do have 5 exterior angles. Drawing them for you. So drawing in the 5 exterior angles so you can see what I'm talking about. 1, 2, 3, 4, 5. They should be equal because it's a regular. Not should, they are equal because this is a regular polygon. 5 times 72 is 360. So now we know this polygon has 5 sides. And then we would be finishing off this lesson if we were meeting face to face. I'd give you this exit slip and I'd be asking for you to put an angle measure in each one of these that's reasonable. So if you're interested in trying this exit slip, I'm going to do a time to ponder pause, and then I will immediately give you a possible answer. There's not one unique answer for these, lots of possibilities. Our last time to ponder pause. All right, resuming to take this up. So I started by looking at this particular angle. I imagined that's what 90 degrees would look like, and felt that's probably close to 70. And in this particular one, 90 was more like that. So it's not far off from 90, so I thought 85 would be appropriate. And this one looks like it's probably just over. 90 would be right there. It's just over 90, so I thought 95 would be appropriate. So that's where I got these numbers from, by imagining drawing your right angle there and comparing how far off I thought it was from right. So now I'm going to add 95, 85, and 70, and I'm going to get 250. And now that's going to force this angle. because I do know the sum of these 1, 2, 3, 4 should be 360. So then this angle should be 360 minus 250, which is 110. And that is a reasonable measure. Again, drawing my right angle in there. Reasonable to call that somewhere around 20. So that's a possible answer. It is not the only answer we would accept. All right, that brings us to the end of this lesson. Hopefully you have a good handle on the sum of the exterior angles of any polygon. If you made it to the end, once again, thank you for watching. Don't forget to like and subscribe. And as always, take care and stay safe.